In this video, we're going to talk about the linear function. And then we're going to talk about how to plot it on the Cartesian coordinates. So the general formula for a linear function is y equals mx plus b. Sometimes you'll see it written as y equals ax plus b. They're the same thing, really, but in this video, I'm primarily going to focus on mx plus b because that's how I learned it. But if it makes it easier for you to learn, when I first learned, I was so confused as to why m was used instead of a or anything else. So if it makes it easier for you to use ax plus b, then you can go ahead and use that too. Okay, so when you plot a coordinate on a Cartesian plane, and this is what a Cartesian plane typically looks like. Let me draw a straighter line. Actually, let me do this instead. So this is what a Cartesian coordinate or Cartesian plane typically looks like. And this is the x-axis, and this is the y-axis. Okay, and x is the input, and y is the output. And if you're into science, then you can look at it this way. X or y is the dependent variable. Dependent actually, no, it's the independent variable. No, it is dependent. Never mind. I'm second guessing myself. Yeah, it is dependent. It's dependent on whatever the input is going to be, x. Well, x is independent. X is independence. It is not dependent on what y is going to be. Okay, so typically coordinates look like this: x, y, an ordered pair in parentheses, and then you have the x coordinates, comma, y coordinate, and then close parentheses. Let me draw a better comma. Okay, so now we know what y and x are, but what are m or a, and what is m or a, and what is b? Well, m is going to be the slope, and you calculate that using rise over run. And b is the y-intercept. And there you could also write it a, put in parentheses a. B is the y-intercept. All right. So how do you calculate rise over 1? Well, it's usually, do like this. This is the formula: y2 minus y1 over x2 minus x1. You can switch it around also if you want, as long as you're consistent. So like y1 minus y2 and x1 minus x2. Yeah, you can do it either way. It really doesn't matter as long as you're consistent. All right, now I'm going to graph y equals x. Actually, I'm going to graph 3 functions: y, not x. Y equals x, y equals negative x. And then y equals, I guess I'll have to make some room here. y equals 2x plus 2. All right, so let's create a table for this, input and output table. X, y, and then for this one, it's gonna be the same thing, x, y. This one's also gonna be the same thing. X, y. All right. Now I'm going to start switching around. I guess I use yellow for this one. So when x is 1, then y is 1, right? When x is 2, y is 2. When x is 3, y is 3, and so on and so forth. When x is 0, y is 0. When x is 1, y is 1. So they exist in pairs. So let's do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'll just do them in twos. 2, 4. For the sake of brevity, I'll just divide them in twos. I won't number all of the points or all of the divisions. Switch back to, okay, switch back to yellow. So I'm going to plot this first line in yellow. And it's not necessary to draw on the scale, but it's close enough. You just have to pretend that it's drawn the scale. All right. Let's draw a line through here. And at the end of the day, this is what it looks like. This is generally what it looks like. Again, it's not perfect, but this is just to give you an idea. All right. Draw arrowheads here to indicate they continue on to infinity. And then this one is going to be, I'm going to use orange for this one. So when x is 1, 1, 2, 3, 4. Actually, let me use different values. -2, -1, 0, 1, 2. So when x is -2, well, negative times a negative is positive. So y is 2. X is -1 is 1, 0, -1, -2, and so on and so forth. So it's basically an inverse. Well, not really an inverse, but it's the inverted line. It has a negative slope, it goes the opposite direction and everything. So let's draw that in. It's supposed to look something like that. And then last but not least, we work on this one. Y equals 2, so let's do -2, -1, 0, 1, 2. -2 times 2 is -4, plus 2 is -2. -2 times -1 is 2, plus 2 is 0, 0, 2, 4, 6. Should continue the pattern. So remember, B is the y-intercept. This is B. In fact, let me just write that in. This is B. And this is A or M. And then, of course, these are X and Y respectively. So B is the y-intercept. Recall that B is the y-intercept. So you got 2 here. And then the slope is 2 is 4, 2, and then -2. One, 2, 3, 4, 5, 1. Actually, that's 2. 1, 2, 3, 4, 5. So Let me get a line here. Continue to this is what it generally looks like. So we got -2, -3 times 2 is -6 plus 2 is -4. So it's -3 to 3, 1, 2, 3, 4. Yeah, something like that. Again, it's not perfectly aligned, but it's just to give you a general idea. Okay. Draw a better arrow. All right. So there you have it. There's the basic of a linear function. And this coordinate here is called, or this coordinate plane is called a Cartesian, T-E-S-I-A-N plane, named after the French mathematician René Descartes. The last thing I want to do real quick is to go over how to find rise over 1. Now we can do it one of two ways. Let's start with this one here. So y2 minus y1. So 2 minus 1, or we could do 1 minus 2. And I'll show you that it really doesn't make a difference as long as you're consistent. Now let's do x minus 1, 2 minus 1, or 1 minus 2. So this is going to be 2 minus 1 is 1, 2 minus 1 is 1, so it's going to be 1. 1 minus 2 is -1, -1, don't have -1, which equals +1 again. Another way you can do it is by following the rise over run. Remember the rise over run formula. So this would be the rise. So let's say you want to find the slope of the linear, or the m, or so you want to find the m of the yellow function. Then it would be 1, you go up 1, from one point to the next, you go up 1, and go 1, you go to the right 1. So 1 to 1, so the slope would be +1. And then I think we can see the pattern consistency. Since it's negative, and the slope is going to be -1, m equals -1. Or you could also say a. And for this one, yeah, a is going to be 2. But how do we know this? Well, let's go here. 1, 2. So 3, 4, 1. 2 divided by +2 plus 1. 2 divided by 1 equals 2, which equals a. And there you go. Those are the basics of the linear function.